Welcome to eDay13. This is Thursday's lesson. It begins with a warm-up. I would really like you guys to pause this video and try this warm-up on your own, and then you can unpause and check your answers. So please pause the video now. Welcome back. Here are your answers. The first one is -7, 5. Did you write your answer as an ordered pair? And the second one, we have two inequalities. The first one is our +3, and then we're going up 1 over 3. It is a solid line, so it's equal to, and it's shaded below, so it's going to be less than. Our second graph, our inequality, is at -3, and then up 1 over 3, but it's shaded above, so it's going to be greater than or equal to. Next, going into today's lesson, we are going to be finding solutions to nonlinear systems, but instead of graphing them like we did yesterday, we are going to be doing it algebraically. For this first one, we have a parabola, and we also have a line. Let's see if we can figure out how to find the solutions to the system algebraically. If you think of elimination, this problem, if we added up our equations, the y's would eliminate very nicely without even needing to multiply by anything. And then we have x squared plus x, and then on the right side we have equals 2. This is now something that is factorable, so we can get it equal to 2 by subtracting over. And let's go ahead and factor. What multiplies to -2 and adds to 1 is a +2 and a -1. Solving, we end up with x equals -2 and 1. So now we know that we're going to have two solutions, and the x coordinates of those solutions are -2 and 1. Now, how do you get the y coordinate? You can pick either equation. I think I'm going to pick the bottom equation. It looks a little simpler. And so off to the side, I'm going to write x plus y equals -2. I'm going to first replace my x with -2 and then solve for my y. When I add 2 over, I end up with y equals 0. Then I'm going to take that same equation, but this time instead I'm going to replace my x with 1. So I have 1 plus y equals -2. Subtracting the 1, we end up with y equals -3. If you were to graph these, you would find those would be the two intersection points, but algebraically we were able to also get those answers. On to the next problem. This one is set up very nicely for substitution. So for substitution, we're going to take, if you see how this says y equals, and we're going to replace it for the y in the other equation. So we'll have our x plus 2, but we're going to replace this y with our x squared plus 6x plus 9. So replacing this entire thing. And then from there, we're just going to continue solving. So we have x, and I'm going to distribute my 2. So 2x squared plus 12x plus 18 equals -2. And let's get this organized so that we're able to factor it. Combining like terms, I'm going to combine here my x with my 12x. It gives me 13x plus 18 equals -2. And then we want to make sure that it's equal to 0 to factor. So we're going to add 2 to both sides. And that gives us 2x squared plus 13x plus 20. And now it's time to factor. Why don't you pause this video and factor however you like to factor. Welcome back. The factor form is 2x plus 5 and x plus 4. If we take this factored form and we solve for our x, our two solutions are x equals -5/2 and -4. finding out what our ordered pairs are, we have our x is -5/2, and we're going to look for the y, and then our x is -4, and we're going to look for the y. The easiest place to plug in is this first equation that has y equals x squared plus 6x plus 9. And I'm going to write that off to the side. Now feel free to use your calculator for this. Remember, when we plug things into our calculator, I'm sorry, that should just be a y equals. When you plug things in, if you have a negative, it must be in parentheses as you plug in with the calculator, and then you square it, you will get a positive. So I would type that into your calculator. If you want to do it by hand, that's fine. And you end up with a y coordinate of 1/4. Then we're going to do the same thing. We're going to replace our y. Make sure you use parentheses. And when you plug that into your calculator or do it in your head, you end up with 1. And then on to our next problem. This problem, I would also do substitution. Elimination will not work. Don't try to square things, because if you square them, you end up with a middle term of xy, which would not be what you were intending. What I would do is take this equation, and we are going to be solving for a letter. This happens to be a circle and a line. It doesn't really matter which letter you solve for in this problem. Some problems there might be a letter that's easier, but let's just go ahead and solve for y. So y equals -x plus 7. In our other equation, we're going to take this and replace our y with it. So our top equation is x squared, but we're going to replace the y. And remember, we're going to replace the y here with -x plus 7 quantity squared equals 25. Now, I would really suggest that off to the side, we take this -x plus 7 and we square it. When you square something, you're going to be multiplying it by itself and foiling. Other students like to square or multiply using their box. So take a second and try multiplying this yourself, or you can stay with me and do it. We end up with a positive x squared, a -7x, another -7x plus 49. So this simplifies to x squared minus 14x plus 49. And we're going to replace that for that blue. We still have this original x squared, and our simplified equation is x squared minus 14x plus 49 equals 25. And let's combine like terms and get it equal to 0. Combining like terms, we end up with 2x squared minus 14x. And if you minus your 25 over, we have plus 24 equals 0. Now remember, when you factor, you're always going to look for your GCF. Here we have a GCF of 2. So factor out your 2, you're left with x squared minus 7x plus 12. And so we're going to take this factored form, and we're going to take this and finish factoring it. The 2 will hang out in front, and what multiplies to 12 and adds to -7 is -3 and -4. When you solve, you don't need to worry about the 2 that's in front because there's no letter with it, no variable. When you solve, you get x is 3 and then x is 4. Setting up my ordered pairs, I have my x is 3 and my x is 4. Now, you won't always have your x values as the one that you're solved for first. It just depends on the problem. I would then suggest taking, to find your y values, I'd plug it in right here. So I'm going to zoom in and I'm going to rewrite that. We have y equals -x plus 7. So plugging in, replacing our x, we'll be able to find our y value. So y equals negative 3 plus 7 gives us 4. And then if we replace this time with our x with 4, we would have y equals negative 4 plus 7, which is 3. Okay, 2 more to go. The next one is saying find two numbers whose sum is 10 and whose squares differ by 20. So we're going to call our two numbers x and y. So they're going to sum, meaning they're going to add, is means equals 10. They're going to add to 10. And their squares are going to differ by 20. So their squares are going to differ by 20. The word differ is subtract. Now, I recognize that some people are going to be able to come up with the numbers in their head, but I'm going to request that you guys actually show the two equations and then the algebra work for it. For this problem, the easiest way is going to be to take one of your letters and solve for it. In this problem, I'm going to choose to solve for my x. So I'll have x equals subtract the y over. And then I'm going to take this and replace it in my other equation. So negative y plus 10 squared minus y squared equals 20. Now, just like we did for the other problem above, I want you guys to pause this video and try squaring this and foiling it out to see what you get. Welcome back. When you multiply this out, we end up with y squared minus 20y plus 100. Then we want to continue writing this minus y squared equals 20. Very conveniently, the y squareds cancel out. It's no longer a quadratic. And we are left with negative 20y plus 100 equals 20. We're going to subtract our 100 to get negative 80 and divide by 20 to get 4. So if one of our numbers is 4, remember they're going to add 10. So if one of the numbers is 4, the other number is 6. Here is our last problem. Find two numbers who have a sum of 194. Whose squares have a sum of 194, and the squares have a difference of 144. So they're going to have a sum of the squares equal 194. And a difference of their squares equals 144. Now this problem is set up very nicely for elimination. If you add them up as they are, your y's are going to eliminate. And we get 2x squared. And if you add that up, it's 338. Using your square root method, the first thing we do is divide by 2. And we get x squared equals 169. And when you take the square root, don't forget the plus or minus. So now we want to come up with our different combinations. We know our numbers are 13, or our x's are positive and negative 13. And I'm going to come to the very first equation that we had here, and I'm going to replace my x squared. So if my x squared was 13, we got 13 squared plus y squared equals 194. And you can think of it as 13 squared or even the negative 13 squared. When you square it, we're back to our 169. To solve for our y, if we subtract 169, our y squared equals 25. And square rooting, we will have plus or minus 5. So now they want to know the combinations. So our combinations are going to be 13 and 5, both positive. We have 13 and negative 5, negative 13, 5, and negative 13, negative 5. I do want to have all of these 4 listed out. Please do not just write plus or minus 13 and plus or minus 5. The reason is I want you to notice that there are actually 4 different solutions. If we were to graph these, one of them is an ellipse and one of them is a hyperbola. And that is why we would have 4 solutions. And so I do want you listing these out. The only reason I don't have it listed as an ordered pair is you could switch the 13 and the 5 of who was X and who is Y. But please list the 4. Today is E13. This first question says verify that these are the solutions. So you can see your solutions here. To verify means you're plugging in and making sure it's true in both equations. And then we have, looks like 4 problems that should mirror the notes that we did, and then 2 that should mirror the last 2 problems. I need to see work for all of these, and you can do it on paper, you can do it on Notability, and you can submit it to eDay13. I hope you're